All right, last lecture of the cardiovascular unit, final challenge of the respiratory system. And that challenge is when we exercise and when we reach heavy intensities, our ventilation can increase by 20 times or even more. So that means that it costs more for us to do that breathing, or in other words, we increase the work of breathing. And so we need to do whatever we can to minimize the work of breathing. So there's a concept called respiratory steal. And so during max exercise or heavy exercise, it's possible that 15% of the total oxygen that's being used by your body is going to your lungs, okay, or going to your respiratory muscles, not to your lungs. And so as a result, if you've got high blood flow to your respiratory muscles, that means you have decreased blood flow to your skeletal muscles, to the ones that are actually doing the exercise. So you won't be able to work out as hard or as long. And so we've got this figure here. So as the work of breathing decreases, we can send more blood flow to our legs. And so we see that from this figure here. So when we have low work of breathing, we have high blood flow to our legs. We have high work of breathing, we have low blood flow to our legs. This makes intuitive sense, but it's just one of those things that maybe you haven't thought of before. And so there are a couple of ways that we can increase our minute ventilation. Okay, so we can either increase the size of our breaths and or we can increase the frequency of our breaths. Now notice that at light exercise, what's happening, so here's our tidal volume, and take into account the frequency of these waves and the size of these waves. Okay, notice that frequency doesn't change a whole lot, but our breaths get bigger. And then moderate exercise, again, frequency is not changing a lot, but the breath size is getting much bigger. When we get to heavy exercise, they're huge, and it's really not until the frequency is getting bigger, but when we get to max exercise, it's, we've tapped out our frequency and the size is as big as it can get. As we go up on this figure, that means we're taking more air in. As we go down on this figure, we're breathing more air out. Notice that we don't ever come close to filling our lungs all the way up when we breathe in, and we don't even fill them all the way up when we breathe out. And the reason that we don't ever fill our lungs all the way up or all the way out can be shown by this figure here. Okay, so on the x-axis we've got pressure, and don't worry about transmural pressure, trans-lung pressure. Just think about the pressure that's needed to either increase or decrease volume, and then on the y-axis we've got volume. Okay, notice that as we get close to total lung capacity, or as we get close to being close to residual volume, that the slope of these lines is much smaller. So in other words, as we get from here to here, we have to generate a lot of pressure, but we're not getting much increase in volume. In other words, we're not getting much bang for our buck. Okay, this is an inefficient way to breathe. If you don't believe me, take a big breath of air in, fill your lungs all the way up, and then try and breathe normally. And what I mean by that is take typical size breaths in and out. It's very uncomfortable because you have to generate so much pressure to get air in, or if you breathe all the way out and do the same thing, it takes a lot of pressure to get air out. And so we want to stay on this steep part of the curve as much as possible, because for a relatively small change in pressure, we can increase our volume by quite a bit. Okay, and we can see this from something called a flow volume loop. Okay, these are a little, they can be a little confusing at the beginning, and we'll talk about these in class. There's no time component here, but notice that there's volume and there's airflow. As we go to the left, we're actually filling our lungs up with air. As we go up, we're exhaling. Okay, and so what's happening here is we're taking a big breath, or we're inspiring, and this is a big maximal inspiration, so we fill all the way up, and then we blast it out as hard as we can, and we keep breathing out for as long as we can. Okay, and so what we're trying to do here is we increase exercise intensity. Each of these lines represents a different size tidal volume. So regular, nice, easy breathing, we're exercising at like 25% of max, 50% of max, 75%, 90% of max, something like that. Okay, to be as efficient as possible, we want to stay away from our maximal effort. Okay, once we hit this line here, once there's crossover or overlap, basically we've tapped out our lungs what we're able to do. And so we want to stay away from that because that means it's requiring a lot of energy and a lot of effort to do anything. And what that ultimately means is that we've hit a point where our ventilatory capacity is greater than our we want to stay where our ventilatory capacity is greater than our demand. But once we brush up against this flow volume loop, this maximal one, that means demand is greater than our ventilatory capacity. So this should say lecture 924, but define respiratory steal and explain how we can minimize respiratory steal.